Okay, so we're going to start off with a show of hands. I'm going to just move out here so I can see you. Who has broken something on production? All right, most of you. Maybe those of you that didn't put up your hands, you forgot about the time that you took all the servers off the load balancer at once. You know, I've been there. Or you touched something in the footer and it broke something in the header. Breaking stuff is a natural part of the development process. Often innovation comes from that failure, and autonomy and speed outweigh weeks of QA process. So a bit about me. I'm Gareth. I'm an engineering manager at The Guardian, and these are mine and my colleagues' experiences about what we broke on theguardian.com and what we learnt from that. So does anyone not know what The Guardian is? No? Cool. This guy over here. We were established in 1821. We met one of the main British newspapers, you know that. We broke Edward Snowden, Panama Papers. We have about 10 million page views a day. And we have three main editions, the UK, the Australian and US editions, and then we have an international edition as well. But some of you may know that the Guardian has a history of making errors, but to wet your whistles, here are a few of the examples of some faux pas that we've seen. So we had a new developer come in and he asked us, you know, how do I test my changes? And he was told, just publish an article in Composer, the content management system. I said, okay, all right. So he went ahead and he did that. But what was failed to mention was to use the test environment. And unfortunately, there's now an article in the Poke with this screenshot of an Apple News article that he published. I've obviously taken his name off. It said, delete this stuff, and then his name. So this could have been caught with a bit better communication. Make sure you test it on the code environment. In this next example, we were getting some complaints from users. They were opening new tabs like this, and they were immediately closing. So we're going through a conversion of a lot of our code base to ES6, and one of our modules had gone through that conversion, and unfortunately, this was the fix. Literally the JavaScript this. So, you know, this was accidentally bubbling up to close to the window and immediately closing any windows that were opened. This could have been caught with a bit of linting, probably. Finally, we had this file. Some of you probably recognize it. It was thought that it was documentation. So what this actually is a browser list file. It's used for configuration for auto prefixer. It was assumed it was documentation. We had this documentation elsewhere, the browsers that we supported. So the file was deleted. Unfortunately, it meant that Flexbox wasn't prefixed anymore, and the home page went a little bit long. So we said, you know, make config look like config. Maybe add a comment at the top of the page. Comments are communication to your future developers. Most of us will recognize this quote, move fast and break things. So The Guardian has a development process and a deployment pipeline like many others. We build and we test locally, and we have pre-push hooks for linting and JavaScript tests. So when we're ready, we open smallest possible PRs. Those pull requests build in Team City, and they run Scala and JavaScript unit tests. And then we require one approval from the team to merge, and Team City builds master. We use our homegrown deployment tool, Riffraff, to continuously deploy to an AWS infrastructure with Fastly CDN and AWS CloudWatch logs watching our back. Door to door, we're 14 minutes from merge to production. And then once we're live, we can watch those error rates and any alerts, and we can dig into the logs if we need. But just as important, maybe even more so, is that we're able to roll back to a previous version in 3.5 minutes. So the important thing to understand here is that every developer is responsible for merging and deploying their code, and they're responsible for watching it out to production, and they're responsible for checking that it works as expected on the live site. I believe that there are 4 main pillars of working in a stable and resilient continuous deployment environment, while making sure that we break things early and we break them rarely. So these pillars are pre-merge monitoring and testing, post-deploy monitoring, making smart and reliable tools, and last but certainly not least, communication. So another hands up moment. Is everyone here, you know, does everyone have 100% code coverage in their unit tests? Hands up if you've got that, right? We all double check our changes locally before merging. We have total confidence in every line of code that we write, but sometimes things slip through. This is one of my own mistakes. I was busy adding some documentation, decided to add a to-do at the top of our code base. It was a simple enough task, whack in a comment, push documentation, no code changes, no worries. Unfortunately, it turns out that HTML comments are different to Scala comments, and we ended up with this beauty at the top of all of our AMP pages. It was a simple mistake with slightly embarrassing consequences. And the most perceptive of you will have noticed this isn't even an HTML comment. And I was pairing on this documentation with another developer. Things slipped through. It happens to the best of us. This is on flow.org with a nice to-do alert. What did we learn from our mistakes, though? Well, we learned that we should probably check the smallest of changes. But with a site the size of The Guardian, and how do we have the confidence that we've not made a change that affects our multiple page templates or our platforms? So we build pull request branches, as I mentioned before, and we run our tests before we merge. But how about we deploy each of those builds so we can do more exciting testing? Well, exactly what one of our developers did. All of our pull requests spin up an instance of our environment in AWS, and they deploy the build of the branch to that instance. So what exactly has this allowed us to do? Well, instead of a manual visual check of all of our page templates, we're able to take automatic screenshots of the pull request branch like this at different responsive breakpoints. It's not perfect. We've been burnt by visual regression testing being too noisy before, but we'd like to look at services like site effect and maybe test individual components in this way. You can also run this on localhost, so developers can test these screenshots before they even push up to GitHub. Having an environment spun up from branches also allows us to run other monitoring, such as this page weight tool, to make sure we haven't busted any page weight limits on our selection of pages. We can also check for simple accessibility mishaps. We run Pally, and these PR environments have opened up opportunities for real browser testing. This is closer to testing what the user sees, and it's closer to measuring symptoms and not causes. Which brings me on to my next point. The methodology of measuring symptoms and not causes is how we approach monitoring in our production environments. This paper by Rob Ereshuk, a site reliability engineer at Google, states that when alerting, we should include cause-based information in symptoms-based pages or on dashboards, but we should avoid directly alerting on the causes. So what exactly does that mean? Well, users don't care about causes of problems like databases being down or data being dropped or endpoints being inaccessible. But what they do care about is error pages. They care about slowness in their pages. They care about pages that never return. They care that when they make changes to their data that they see the updated data. And they care that the features that they expect to be working are actually working. The symptoms-based metrics are reflected in our dashboards. If an alert is fired, we'll often make our dashboards the first point of call. Here we can see for each application in our front-end.com environment that the error response rates. We can see latency, successful requests, and more. And then from these dashboards on the .com side, we know which application we need to go to next and which service. For example, if the article application is playing up, then we check our content API. If discussion is showing problems, then we'll just check the discussion API dashboard. And if fronts are showing issues, then we can head over to the fronts API dashboard. Each service has similar metric dashboards to aid our initial investigation. So in general deployment, as I mentioned before, we ask that our developers follow their change out to production, and then they check it on the live site. To ensure that a developer remembers to check their changes, we use an open source tool built by Guardian developer Roberto called Prout. This will comment on a PR if a change is slow to go out, and then it will comment again when that change has landed in live. The Prout comment has a reminder to check the change on the live site and a link to our dashboard in Kibana. Some of you may know Kibana, but it's a tool that ingests the logs of your applications, your CDN, and anywhere else that you can log from. And it can create metrics and dashboards to enable the charting of just about anything that you give it. Our deploy dashboard here shows engineers the 200s, the error rates, the latency, and it stands as a sanity check that nothing major has fallen over in deployment. But the front-end experience is important too, because our users' experience relies on how our site performs. It's important for us to track the front-end metrics, things like load times or time to interactive. We need to make sure that a deployment hasn't caused a major issue and that our site doesn't decrease in performance over time. We use a service called Speed Curve. You've probably heard of this as well. It's a tool for measuring browser performance metrics built on top of web page test. And it runs a test periodically after every deployment. If we've broken our budgets for metrics such as time to first paint or start render or visually complete, then we're alerted in our Slack channel to a problem. We also use Google Analytics here for performance events and for real user monitoring. We can aggregate the page load times and custom metrics such as when our JavaScript bundles are requested and how long they take to parse for real users. This allows us to monitor the changes and drill down into particular browsers or devices to investigate bottlenecks. So as every developer knows, undefined in JavaScript, it'll take down your application, it'll not care about you or your users one bit. But Guardian developers learned early on to make sure that their JavaScript was sandboxed. We wrap our modules and our bootstraps in exception-catching wrappers that if we do something wrong, it only takes out the functionality of that specific module. We catch all our exceptions and we report them to Sentry. Sentry is a tool that aggregates and reports JavaScript errors, and it gives us another avenue of real user monitoring, but from the point of view of things going wrong. With our recent conversion of the codebase to ES6, we also integrated Flow into our environment. This gives us a level of type safety and hopefully removes many of the undefined and other JavaScript errors that we often saw in Sentry. Finally, our editorial tools team has a separate type of QA monitoring with a tool they called ProdMon. That's short for production monitoring. It's a synthetic monitoring application that uses WebDriver under the hood. And you can read more about this type of monitoring here, but in short, it's designed to test each stage of a user flow and doesn't progress until the previous step has passed. So for example, a specific flow is the creation and publication of an article in Composer, our content management system. It tests that the article has appeared in our content API, and then that the article appears on the live site. The article is then taken down and it's tested that it's not available each step again. This type of monitoring works great for our editorial tools, and it's a great approach to running periodic tests on production, both in our user flows and in the tools we build. It also works well for testing the tasks that users don't often use, to make sure that they continue working so that when you really need them in that critical moment, you'll know that they'll perform their job as expected. Which leads us on to our next point. Making sure that your tooling is resilient and reliable is paramount to stability in your platform, especially when those tools have the ability to be more damaging than a user expects them to be. So, story time. In March last year, we had a bad deploy. Things went wrong and we served 500s from our origin servers. Sounds like an end-of-world scenario, but thankfully not, because our CDN is set up to serve stale pages from the CDN cache if the origin servers are erroring. This is a lesson in itself. It's often saved us against our own and third-party poorly origins. It's a good pattern to give you a safety net when something breaks and some time to fix it. But this lesson is really about reliable tooling. And a tool that our central production team often use is this cache clear tool. You might be able to see where I'm going here. This cache clear tool removes the page from the CDN cache. Unfortunately, because our homepage was failing to update, thanks to serving stale, it was avoiding showing users a 500 error, but it deemed that there was a cache issue. The cache issue suddenly became this 500 issue when the stale homepage was cleared from the CDN cache. Our tools that were very reliable in clearing the cache were too dutiful in that job, and they undermined that reliability by failing at a crucial time. This taught us the value of making sure that our tools not only do their 99% of the time job, but remembering that they have a 1% critical situation role. We learnt to build checks into our tools to avoid destructive behavior. The cache clear tool, for example, will now hit the origin servers, and it will only allow clearing the page from the cache if it receives us 200 from the CDN. But how else could that cache clear tool have been avoided? Well, a message in Slack from the developers looking at the issue or our central production team would have saved us the panic of showing 500s to our users. You can have the smartest tools in the world, but if you don't coordinate when things go wrong, or when you're going to make a significant change, or even when you're just fiddling with a testing environment, then the likelihood of breaking things is significantly increased. But communication needs work. There needs to be an open, honest, no-blame culture where people feel psychologically safe. They can admit to their mistakes freely, and they can talk about why that happened without fear of repercussions. Our central production and our user help teams sit nearby to us, and we have open invite demos within the pipeline work so they can see what's coming up and be prepared for it. When there's a problem, we head over and we talk face to face with them. It's important to never underestimate the power of email to skew meaning. Some of you might remember the GitLab issue. It's a great example of open, honest communication when things are going wrong, really, really wrong. So a developer accidentally removed most of their data from the production database. They lost about 5,000 comments and 5,000 projects issues. But the way they handled themselves was a great example of good communication. A few of their developers jumped into this public live stream to discuss the problem, and they had a completely public Google Doc with a timeline of events with what they had tried. The community reacted so positively. People who are using their tool and seeing the problems were sending love and hugs as a team, especially to team member 1, who was the deleter of the database. It really showed how people appreciate transparency when things are going wrong. So I've talked a bit about communication before code goes out the door, and a little bit about when things are going wrong. But what about after an incident has been resolved? After all, those are the times when we can really learn what went wrong and why. At The Guardian, we have postmortems the day after an incident, or incident retrospectives. These are open invite with mandatory attendance from the teams that maintain the system and the engineers that were on call or resolved the issue. These are the true what and why environment. They're free of finger pointing or arguing, and they're laser focused on finding remediation tasks to shore up the tools and systems that didn't work as expected. So they provide a short description of what happened, and they pull together a timeline of events. Things like, when did the support devs get called? When did the monitoring notify the teams? When were communications sent to affected users or statuses updated? Next, we talk about the questions that were raised. Things like, why didn't an alarm go off? Why doesn't a section have unit test coverage? Why isn't something protected by the cache? These questions are designed to tease out the bullet points for the next section, the actions. The actions will often vary from investigations to answer the previous questions. Things like adding health checks or alarms to systems and checking that all the similar sections are covered. We might add logging to make it easier to debug in the future. And we also want to make sure that systems are more robust by adding things like exception catching or providing fallbacks or failovers. These incident retrospectives create a virtuous cycle. Each post-mortem teaches us how to build more robust, resilient systems that filter into the next product or feature that we build. So it can feel like a disaster when things are going wrong, but the majority of these issues, they go unnoticed by our users. By ensuring that we have robust pre-merge monitoring, post-deploy monitoring and alerting, robust tools and excellent communication between our teams, we can ensure that when things do go wrong, we know and we can fix them before our readers notice a problem. Each thing that breaks improves the robustness of our tools, processes and infrastructure. All in all, we're moving forward. We're building the tools, the checks, the processes and the communications so that we can follow Facebook's new mantra. It's not quite as catchy, but it's certainly a better strategy for building websites and applications. The move fast with strong and stable infrastructure. There you go. Any questions? Thank you very much.